Christmas like Mr. Kelly and some dubstep. Holy cow. Been looking at some famous artists here with each algebra teacher. And Mr. Kelly doesn't really have a famous artist as much as he just loves dubstep. The Duke and dubstep, even to Mr. Grinch. That is impressive. All right, we're going to solve some rational equations. Let's take a look at solving some of these bad boys here. Two methods for doing this. So the first one is just kind of like, hey, what do we do with fractions? So we're looking at these rational equations. One method is to get a common denominator. So you can get a common denominator, so I can add these fractions. I got a 1/3 and x over 4. So the least common denominator would be 12. So I can times this side by 4. What do I do to the bottom? Do it to the top. And then if I want to get 12 on this side, I times this by 3, I times this by 3. So you're more than welcome to say, I'll just get a common denominator and add these two things together. So I'll get 4 over 12 plus 3 over x over 12. And now I can solve for x by adding these together. So if I add these together, I get 4 plus 3 over x all over 12. And then what am I going to have to do to get rid of that 12? Well, you got to times both sides by 12. So I can times both sides by 12. And these cancel. And what am I looking at here? I'm looking at 4 plus 3x equals 24. And then now I can wrap this up, solve the last part here, subtract 4 from both sides, so I get 3x equals 20. And then divide by that 3, you get x equals 20 over 3. So that's super cool. That is one method for doing it. That is great. Not the method we're going to use, though. So all that was for naught. Why? Well, it gets a little bit tedious with these rational equations here. So let's take a look at this one. There's a faster way, which is called clearing the fraction. So if I look at this right off the bat and say, oh, there's 3 and a 4, what's the least common denominator? Well, I know it's 12. Right off the bat, just times everybody by 12. You can do whatever you want to both sides of an equal sign. As long as you do it to both sides, you're totally cool. So if I distribute a 12, now everybody's going to have to get 12 times bigger. You got to do it to everybody in the whole equation. So I can do 12 times 1/3. And then I'm going to add that to 12 times x over 4. And then I'm going to do that to 12 times 2. So everybody gets 12 times bigger. So what is 1/3 of 12? Well, it's 4. It cancels it out. You can think of it, oh yeah, it goes in there 4 times. Remember, this is like 12 over 1. What is 1/4 of 12? Well, it's 3. So I get 3x. This cancels out, gives me 3. 3 times x is 3x. And then 24. So look at that. In one step, I got all the way down to here. And instead of doing all this common denominator, I skipped to the end here. It's like a super shortcut, and I'm right there to wrap it up. Same thing, subtract your 4 from both sides. We already solved this once. I'm going to solve it again. Might as well. You get the 23rd. So see how it cuts out a lot of that work by multiplying by the least common denominator. So that's how we're going to do these. I think it's a much better method in this case. Before we get rolling in that, there's something we got to do, though. So now these are rational equations. I got these the variables in the bottom. If you have variables in the bottom, you got to look for excluded values. So somewhere off to the side, say, hey, man, x cannot equal 0. Remember, you can't divide by 0. That would cause a problem. So I'm going to say, hey, x can't be 0. I can go ahead and solve it. As long as I don't get x equals 0, we're all cool. So if I'm looking for the least common denominator of all these fractions, I got a 3, I got an x, I got a 5. What's the least common denominator? Well, sometimes you just multiply them all together. 3 and 5 can both become 15. And then if I want to get rid of the x, I times it by the x. Now I'm going to distribute that bad boy to everybody. Got to make everybody get that. So if you want to show all the work, you can. You can say 15x times 1 is 15x. That's all over 3. Then you can say 15x times 4 is 60x all over x. And then 15x times 2 is 30x all over 5. But the whole reason we did that is to cancel out these fractions. So they're going to reduce. So what's going to happen here? 3 goes into that 5 times. So I've got 5x. I forgot the x. Oops. I hope you caught that as you were going along. I'm just seeing if you're awake. Just seeing if you're with me right there. That was actually 15 times 4 is 60x. Awesome. And then now what happens here? The x's cancel. So I'm looking at, what, 60? And then the last one, 5 goes into that 6 times. So I'm looking at 6x. So that gets rid of all my fractions. Now you can just get all your x's on one side and you're good to go. So I'm going to subtract 5x from both sides. Subtract 5x. I'm going to run out of room. Holy cow. So I'm looking at 60 equals what? 1x. And that's my answer. Whew, I lucked out. So I'm cool. X is 60 in this case. It's not 0, so I'm cool. So you always double check that excluded value. The answer cannot be that. Awesome. Very nice. Let's do another one. We're just going to kind of do a bunch of these here. Make sure we got the flow. So when I'm looking at these, I want to do the least common denominator possible. You could go ahead and multiply by 18x. It's going to work, but it's going to make your life more challenging. If you look at this and say 3 and 6, what number can they both become? They can both become a 6. So use the 6. It just helps you out. You get smaller numbers, and x is the least common denominator. You could do x squared, but man, it's going to be hard to solve that when you've got that x squared floating around in there. So what I'm going to do is make sure you use the least common denominator. All these can turn into that. And go ahead and distribute this out. So if I'm going to multiply this out, 6x times 2x, let me remember the x this time, that's 12x all over 3x. Then I'm going to say what? 6x times 1 is 6x all over 6. And then 6x times 4, 24x all over 3x. And then things have got to cancel. So I know my x's cancel. I know I'm left with just a 4 here. That goes in there 4 times. And then the 6 over 6 is just 1, so I'm left with 1x. And then 3 goes into that 8 times. The x's cancel. Boom, I'm good to go. Let's just wrap it up, make sure we're cool here. Subtract your 4, subtract your 4. So we're looking at x equals 4. I almost forgot. What are the excluded values? Well, again, x in the denominator, x cannot be 0. So I'm okay. X is 4, it's not 0. I'm okay. Let's not forget that. We should always start with that. So start at the bottom. Here we go. What makes this 0? When does x plus 3 equal 0? Remember, it can't equal 0. So we're saying x cannot be negative 3. So that's an excluded value. Hopefully we won't have to worry about it. Sometimes we will, though. Now I'm going to get rid of the least common denominator here. Remember, everything's a fraction. This is like x over 1. So what do I have here? Well, I've definitely got a 2, and then I've also got an x plus 3. So this is my least common denominator. It's okay. We're going to leave it in that factored form. The reason we're going to leave it in that factored form is it's going to cancel. That's the beauty of this. So let's distribute it. So if I write this all out, I'm going to have 2 times x plus 3 times x all over 2. Oh, I almost did a plus sign. Let's get that out of here. It's a minus sign, so it's a minus 2 times x plus 3 times 1, so it's just the same thing, all over x plus 3. And then the x, don't forget, you're going to have 2 times x plus 3 times x, all over 1 if you want to write it, but we know that's just going to be the top there. So let's cancel some things out. The 2's are gone. I can go ahead and distribute that x and get x squared plus 3x. Ooh, I like this one. The x plus 3's cancel. The whole bottom is going to cancel that thing, so I get a minus 2. And then over there, I'm going to go ahead and distribute some things. So you can distribute the 2 and the x at the same time, or do one and the other. You're going to have with 2x squareds plus 6x. So now this one's a squared. Uh-oh, what do I got to do when I have this quadratic? Well, I got to get everything to the same side. So I'm going to go ahead and bring this x squared over. So subtract an x squared. And that's going to give me, what, 1x squared, which is good. And while I'm at it, I'm going to bring this 3x over. Might as well bring him over. And what is that going to give me? Plus 3x. And then I'm going to bring the 2 over. Remember, I want everybody on one side. So that's a plus 2. I'm going to put plus 2. That gives me a 0. Now I have a shot at factoring this. And I'm going to kind of have to scroll down here. Woo! I hope I gave you more room than I gave myself here. So what happens here? I can factor this. So if I have an x squared, I can set equals 0, and now I'm going to factor this. What multiplies to 2 adds to 3? Well, this is going to give me x plus 2, x plus 1. So what is my final solution? X is going to be negative 2 or negative 1. X is negative 2 or negative 1. Is that coolio? Yes, x can't be negative 3, so I'm okay. This is good to go. Those are both solutions. Pretty awesome. Excellent. How about this one here? I'm going to do my least common denominator. Or some people in this case just think of it like, oh yeah, I'm just saying I need to get rid of that 2x minus 1 over here. I'm just going to do this to both sides to get rid of it. So this is more old school. We've probably done this in the past. Boom, boom, that cancels. And now it's just a matter of distributing the 12. So 12 times 2x is 24x minus that 12 equals 5x plus 6. Let's keep this going. Let's get our x's on one side, and hopefully this part goes fast for you. Subtract the 5, you get 19x minus 12 equals 6. And then we want to bring the 12 over. So add your little 12 over here to both sides. 19x equals 18. Ooh, that is not friendly. Sorry about that. You're going to get some weird fractions. It's totally okay. Divide by 19, and we got our x equals 18 over 19. Not a problem. We can have weird fractions. Was there an excluded value? Should have started with it, Mr. Bruss. You got to start with that. Yes. What's going to happen here? You got to say the bottom cannot equal 0. So I got to solve that. What do I get? Plus the 1. And you get, what, divide by 2. So x can't be 1/2. Is it 1/2? Oh, I'm cool. It's not 1/2. Excellent. So I'm legit. I can't have an answer be an excluded value. That would be trouble. All right, big dog right here. Let's bring the pain. Look at this monster right here. So it looks like a lot, but a lot of times these things are going to factor here. So is there something that multiplies to 12 and gives me 1? Sure, I'm going to do x minus 4, x plus 3. And isn't that convenient? It's the same factors as over here. So before I get too far, sometimes I forget. I got to say, hey, what are my excluded values? Well, in this case, I can't have x be a 4. And you can look at that. Right here it is. And I can't have x be a -3. If I get one of these answers, it's excluded. It doesn't count. I cannot do it. So now I'm going to multiply by the least common denominator, which in this case is x minus 4 and x plus 3. Pretty crazy. But I'm going to distribute that bad boy out to all of this. So if you're feeling good about this and you want to kind of cancel as you go, like some people can totally do that. Like this x minus 4 is going to cancel x minus 4. X plus 3 is going to cancel x plus 3. I'm going to show the steps. But if you're feeling pretty good about this, go ahead and just cancel them out as you go and go straight to the answer. So here we go on bottom. Whoa, let's try that again. Make that an x plus 3 over here. And then I'm going to add what to it? Well, I've got this thing times 5, so I'm going to go for 5 times x minus 4, x plus 3. Man, I'm glad I got a lot of room on this one. And that's all over x plus 3. And then don't forget the last one. I'm going to say it's 2 times all of that, your x minus 4, x plus 3. And all of that is over x minus 4. Now the fun part, I always like this part. It's like I'm getting something done. Boom, cancel, 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 cancel. Get it out of there. So I got the 2x. Over here I got x plus 3, they're gone. So I'm going to say, hey, this is 5 times x minus 4. And then over here, the x minus 4 cancels the x minus 4. I've got 2 times x plus 3. So maybe you went straight to this step. That's great if you did. However you get there, we're all going to get there sometime. Let's just distribute this, kind of clean it up a little bit. So I'm really looking at 2x plus 5x minus 20. Distribute this 2 on this side, and I'm looking at 2x plus 6. And now I need to kind of, let's combine like terms before I do this. 2x and 5x is 7x. And can I solve this at all? Sure, I'm going to get x's on one side. So let's bring the x's over here. I'm going to minus the 2x. Doesn't matter which side you pick. I'm going to try to keep it positive, though. So that'll be 5x. Then let's add our 20 to the other side. And I'm going super fast here. Hopefully the solve an equation part is pretty good for us by now. You guys have solved a lot of equations in your day. Pretty much professionals. We get what? X can be. It better be x. This is the answer. 26 over 5. So that is the solution. Double check with my excluded values. They're not excluded, so I'm good to go. So we're going to get some big fractions there. Not a problem for us. 2 more, and then I'm going to cut you loose on some and see how you do. Here is we could do the least common denominator here. But if you remember old school, let's go old school. Remember we do something like this, 2/3 equals x over 4. And we do like this cross multiply. Remember you can say this times this equals this times this. Like 2 times 4 is 8. And then 3 times x is 3x. You can do the same thing here. If that's going to freak you out, just do the least common denominator again. It's each of these. But if you want to think of this as a cross multiply, so it's going to be, hey, 12 times 2x plus 1, because it is a proportion. It's 2 fractions that equal each other, equals this times this. So it'll be 6 times 4x plus 1. This is much easier than doing the least common denominator because it saves a lot of that canceling thing, but it's the same difference. If you want to do the cross multiplier, if you want to do the other way, doesn't matter. As long as you're getting right answers, that's all I care about here. So distribute it. Let's keep going this way. I like this method. And then 6 times this is 24x minus 6. Ooh, this looks weird. And dang it, I did it again. I hope you do a better job than me remembering. The excluded value. Let's look at this. I know it hasn't happened yet, but I know I had to give an example where it matters. Or else that's just bad teaching is all that is. If I solve this plus the 1, so you get 4x can't equal 1, so x can't equal 1/4. So if I get 1/4, I'm in trouble. Bring that 1 over there, you get negative. Or if I get negative 1/2, I'm in trouble. These are excluded values. Can't be the answer. I don't think it's going to happen this time, though, because what happens when I solve this? Man, if I minus 24x, what's going to happen here? They cancel, and I'm left with 12 equals negative 6. So what does that mean? Can 12 equal negative 6? No, this is no solution. This one has no possible answer. Just not going to happen here. No solution. All right, bummer. Moving on. Man, I hope this is the excluded value example. Let's start with it. This breaks down, it's a difference of squares. So we got x squared plus 3, x minus 3. And I've got these excluded values of what? If I look at this, x can't be negative 3 because that'd be 0, and x can't be positive 3. All right, let's do our least common denominator trick. I'm really multiplying by x squared minus 9, which is this x plus 3. I like it in factored form better, so I'm going to leave it in factored form so I can see it cancel. So if you want to kind of cancel as you go, are we up for that? I don't know. Can we do one of those? We can kind of cancel as we go. I'm going to show the steps still. Still showing the steps. So what do I got? I got x plus 3, x minus 3 times that all by 6, and that's all over x minus 3. That's going to equal x squared, and then I've got my x plus 3, x minus 3, all over x plus 3, x minus 3. There it is right there. And then subtraction, this is a good subtraction one. We've got that 4x, and then our x plus 3, x minus 3. All of that thing is over x plus 3. And now let's do the fun part. Let's cancel it all out. So x minus 3. Why did I put 6 here? Dang. That's really a 3. Let's just change that. That was supposed to be x minus 3 up there. I don't know why I put 6. I got ahead of myself. Maybe you caught that. Boom. There it cancels. It's x minus 3. Can't even read my own writing. This one's great because they both cancel. X plus 3, x minus 3. Gandhi. X plus 3, x plus 3, and that is out of here. So let's distribute that 6 back up here. Don't forget, it can be after them. We're still going to distribute them. We're looking at 6x plus 18, and that's going to equal, that's all gone, 8x squared minus, we got to distribute it. Now be super careful with this negative. Remember, when you distribute the negative, it's all of this stuff up here. So I'm actually going to distribute the negative. I'm going to say, hey, let's distribute that negative to everybody. However you can remember to get it, or do the answer and then make it all negative. But I'll distribute negative 4x, so I'll get negative 4x squared plus 12x. That is the hard part right there. You really got to remember to change that sign of the whole thing. Now, I see some squares here. Let's clean this up. I've got 4x squared. I've got, 12x over here. I've got 18 and 6x. There we go. I'm going to have to give myself a little more space. Now, bring everything over to one side. So I like to keep my first term positive, so I'm going to bring the 6x over here. I'm going to bring also the 18 over here. And what are we looking at? There's the 0 I want, so I've got 4x squared plus 6x minus 18. That's not so friendly. What can I do here? Well, I can take out a greatest common factor, so I can actually take a 2 out of this. So at least that breaks it down a little bit. That turns into 2x squared plus 3x minus 9. Now I got to factor that. Kind of a bummer, so we got to do last time's. This is a big problem. Big old problem here. 9 times 2. We're looking for, hey, what multiplies to 18 adds or subtracts to 3? So if I'm looking for that, what's going to do it? I think it's going to be 6 and 3. So a couple different ways to do it. I'll do it by grouping, I suppose. Would be the best method for me to do it by. So I've got 2x squared. Let's put the minus 3x plus 6x minus 9 here. So, and I'm going to need more, keep extending this page. I'm still rolling here. So I rewrote 3x as this, same difference. Why did I do that? Well, keep bringing this 2 down. I can group it. Remember, cover up that one part, and I can pull an x out of this. So I'm looking at 2x minus 3. And then if I cover up this side over here, what can I pull out? I can pull out a 3 on this side. So I'm looking at 2x minus 3. Well, that worked out well, didn't it? Then this is the coefficients here are going to be one of my factors. So I'm looking at x plus 3. And then over here, I'm looking at 2x minus 3. And let's solve it. So when I finally solve it, I should have been putting equals 0 this whole way. I was just factoring, regrouping it. All right, so when I finally solve this, what do I get? Well, x is, it can be. It's not can't be. This is definitely my answer. My answer is negative 3. And if I solve this one, I get 3/2. So you guys said equals 0 to solve. Double check, what were my excluded values? Did I make up an example that worked? Holy cow, this is a problem. Right up here, I said x cannot equal negative 3 or 3. I can't do it. That was my excluded values. What did I get here? I got a negative 3. That is trouble. So this is called an extraneous solution. It means it doesn't count. Ooh, sorry, I'm going to write that out. Extraneous. This solution right here is extraneous. It's not going to count. This is my only solution. So because of an excluded value, when you multiply by these x's and do different things, you're introducing values that can't be true. This is one of those, cannot be true. It's an extraneous solution. Cross it out. Don't count it. Label it. That's my real solution, 3/2. Woo! I knew I had an example. I didn't know it was going to be that tough. That was a monster. If you got that right, you are styling. Okay, here are 3 for you to try. Be super careful with this negative in the second one. Make sure you distribute that on out. Make sure you pause it. Try it. I'm going to throw the solutions up. Good luck. All right, here we go. So I just threw the answers up there for you real quick. Hopefully these went well. The last one was tricky, man. You only got one answer, which was 3, but careful is an extraneous solution because that's an excluded value. So because there's not another one, this is actually no solution. You can't solve this one. The only possible one is that extraneous one. Doesn't work because it's an excluded value. Excellent job on this. Good luck on the math check. Peace out.